In topic one, we're going to be looking at three different things. We're going to be looking at how to find the prime factorization of a number. We're also going to be looking at how to find the greatest common factor of a number and the least common multiple of a number. So let's start off with the prime factorization. So to find the prime factorization of a number, we are going to break down that number into a list of prime numbers. So remember, in the introduction here, we talked about what a prime number is, if we just scroll up here. And a prime number is a number with exactly two factors, one and itself. So we're going to come up with a list of prime numbers that when we multiply them together, we get this number here. Now there's two methods that we can use to do that. The first method is the factor tree, and this is the method you're probably going to end up using more than the other one. The other one I just kind of have to show you. So factor tree, these are kind of fun. I like them. What we're going to do is we're going to start off at the very top of our tree with the number. So 3,300. And what we're going to do is we're going to break down this number into two numbers that multiply to get 3,300. So I'm going to do my little tree extensions there, and two numbers that multiply to that. Now, there's a bunch of different options you can choose. I'm going to choose 33 and 100, because 33 times 100 gives us 3,300. Now what we're going to do is we're going to keep working our way down this tree, and we're going to keep splitting up these numbers into two numbers that multiply to that number. So here, 33, I know 3 and 11 multiply to get 33. For 100, let's do, how about 4 and 25? You could have also done 10 and 10, that would also work. Now you want to keep working your way down this tree until you can't go anymore. And when you can't go anymore, it's going to be because it's a prime number. So let's look over here, 3. The only thing we could break 3 down into is 3 and 1. There's no other numbers that multiply to 3. So that means we're done. We could stop at 3. So I'm just going to erase this red part here, and I'm going to circle the number 3 because we're done for that part of the tree, that branch. 11 is also a prime number. The only numbers that multiply to 11 are 1 and 11, 1 times 11. So 11 we can put a circle around as well. 4, however, we can split up into 2 times 2. And both of these 2's here are also prime numbers. And we can split the 25 up into 5 times 5, and 5 is also a prime number. So now we have a bunch of numbers circled. They're all prime numbers. So our final step here is to write the prime factorization. So when we write down the prime factorization, all we're going to do is we're going to multiply together all of these circled numbers. And you'll see when we multiply all of these circled numbers together, it'll equal 3,300. And yes, you could probably use a calculator to do that, but we aren't going to be using calculators in this unit. When we write the prime factorization down, please write the numbers, or try to write the numbers in ascending order, meaning starting with the smallest numbers. So in this case, the 2's are the smallest. So I'm going to write 2 times 2. Then we're going to move to the 3 times 3. Then we're going to move to the 5's times 5 times 5, and finally times 11. And I'm using little dots there for multiplication symbols. Try to get away from using x's for multiplying. It's going to get really confusing when we start using variables that are x's. Okay, so then we can simplify this prime factorization one step further by combining the numbers that are the same and using powers. So for instance, 2 times 2 is 2 to the power of 2. Then the 3 can just stay the same. The 5's we can write as 5 to the power of 2. And the 11 we can just keep the same. So our prime factorization would be 2 to the power of 2 times 3 times 5 to the power of 2 times 11. And double check this. Try putting it in a calculator and see if you get 3,300. I guarantee you will. One more thing to add about method one, if you decided to break up these numbers differently, so let's say you took the 100 and instead of breaking it up into 4 times 25, you did 10 times 10, you would still get the exact same prime factorization at the end. All of your numbers will be the exact same as mine. So there's really no way you could mess this up. Now let's look at the repeated division. This method is a little bit more confusing. It's not that bad though. Will you use this method a lot? Probably not, but I have to show you it anyway. So repeated division, what that is we are going to divide the number until the answer is 1. So let's start off with our number, 3,300. And I'm just going to start dividing by prime numbers until the answer is 1. So a prime number that we could divide by is, let's just do 2. I know 3,300 is even, so let's divide by 2. So 3,300 divided by 2 is 1,650, or 1,650. Now what we're going to do is we're going to take this 1,650, that's supposed to be an arrow, and we're going to write it over here. And this is now the number we're starting with, and we're going to divide into. So let's divide 1,650 by a prime number. So the prime number I'm going to choose again, I know that's even, so let's choose 2. So 1,650 divided by 2 is 825. Now we're going to write 825 over here, and we're going to divide it by a prime number as well. Let's do the number 3. You could also have done 5. 825 divided by 3 is 275. Now we're going to put 275 over here, and let's divide this one by 5 now. So we get 55. Now 55 divided by, let's do 5 again. We get 11. And now we have 11 over here. The only numbers that we can divide 11 by are 1 and 11 because it's a prime number. So let's divide it by 11. And our final answer will be 1. Would you look at that? We divided until we got 1. So now when we're looking at the prime factorization here, we're going to look at all of these numbers that we ended up dividing by. Those are our prime factorization numbers. And if you look above, they match the numbers that we got by using the factor tree. So the prime factorization, again, is exactly what we got above. We got 2 times 2 times 3 times 5 times 5 times 11. Or in other words, 2 to the power of 2 times 3 times 5 to the power of 2 times 11. So that is 2 methods to get the prime factorization. Now we are going to look at getting the greatest common factor of 2 numbers. So greatest common factor, this is often referred to as the GCF. And what we're going to do to find that is we are going to use these factor trees that we just learned in the previous example. Now let's think back to what a factor is. Remember, a factor is a number that divides into a number. So we need to find the greatest, aka the biggest number that divides into both 138 and 198. So we're looking for the biggest number that divides into both of those numbers. And a way we can do this is by using factor trees. So I'm going to make a factor tree for both 138 and 198. So let's break these down as much as we can until we get the prime factorization. So this one, let's do 2 times 69. 2 is a prime number, so we could circle that. And now we're going to do 3 times 23. 3 is a prime number, and also 23 is a prime number. So that was a really short tree. We're done. 198, we're going to do 2 times 99. 2 is a prime number, so we can circle that. And now we're going to do 3 times 33. Sure. 3 is a prime number, and we can break down this 33 into 3 times 11. So the prime factorization of this first one here is 2 times 3 times 23. And the prime factorization of this one over here is 2 times 3 times 3 times 11. Now here are the two steps to finding the greatest common factor. The first step, after we get the prime factorizations, you want to circle the factors that appear in both prime factorizations. So in other words, we're looking for pairs of numbers in the prime factorizations. So let's look at these prime factorizations here. Both of them have a 2, so I'm going to circle the 2. Another pair we can get is 3. Both of them have a 3, so we're going to circle a pair of 3s. Now we can only circle one 3 in this one over here because there's not a 3 to match the second one over here. Now there's no 23 in both of them, and there's also no 11 in both of them. So these are actually just the two numbers that we can circle. So our second step, and this is actually our final step, the greatest common factor, or the GCF, is ... We're going to take the two numbers we just circled, multiply them together, and boom, we have the GCF. So the GCF is 2 times 3, which is equal to 6, and that's our greatest common factor. So 6 is the biggest number that divides into both 138 and 198. Now let's take a look at the least common multiple. Now it's easy to get least common multiple and greatest common factor confused because they're similar but kind of like opposites of each other. When we're dealing with least common multiple, let's remember what a multiple is. It is like skip counting by the numbers. So when we are determining the least common multiple, we are going to skip count by all of these numbers here, so 18, 20, and 30, until we reach the first common number for all of them. So eventually we're going to reach a number when we skip count by each of those numbers that matches. That will be the least common multiple of those three numbers. But we can actually do this by using factor trees. Yay! So let's take all of these numbers and make a nice little factor tree from them. So 18, we're going to do 2 and 9. And 9 we can break up into 3 times 3. So there's our prime factorization. 2 times 3 times 3, or 2 times 3 squared. Then we can take 20, break it up. Let's do 2 times 10, or break that 10 up into 2 times 5. So the prime factorization is 2 times 2 times 5, or 2 to the power of 2 times 5. And finally, we got 30. We'll do 3 times 10, and then break that 10 up into 2 times 5. So let's put these in order from least to greatest. 2 times 3 times 5. And there's nothing we could combine there. So we're all done. Now I'm just going to write on the side here what the least common multiple, and actually we're going to write least common multiple as LCM. So I'm going to put the least common multiple is the product, and remember, product is the answer to a multiplication question. So the product of two numbers is multiplying them. So the lowest common multiple, or the least common multiple, is the product of the greatest power of each prime factor. And this one's a little more confusing than the greatest common factor. So what we're going to do here is we need to find the greatest power of each prime factor. Now the prime factors are the ones we have listed in our prime factorization. So let's go through each of the numbers or each of the factors we have in our prime factorization and see what the greatest power of it that shows up. So I'm going to say the greatest power of ... 2, let's start off with the lowest number, which is 2, is What's the greatest power of 2 we see? Well, this one would just be 2 to the power of 1. This one's 2 to the power of 2, and this one's 2 to the power of 1. Because remember, there's like an invisible 1 exponent on these numbers here. So the greatest power of 2 that I see is 2 to the power of 2 in the middle one. The greatest power of 3 is, well, we have 3 to the power of 2 there. We don't even have a 3 in this one. And then we have 3 to the power of 1 on that one. So the greatest power of 3 is 3 to the power of 2. And finally, we have 5. We have 5 to the power of 1 here and 5 to the power of 1 over here. So the greatest power of 5 is just 5 to the power of 1, or just 5. So our final step to find the least common multiple is we're going to multiply all of these numbers here together. So I'm just going to zoom in a little here so I have a little more room. The least common multiple is ... We're going to multiply these numbers together. So we're going to have 2 to the power of 2 times 3 to the power of 2 times 5 to the power of 1. So if we multiply all these together, we have 2 to the power of 2 is 4, 3 to the power of 2 is 9, and 5 to the power of 1 is just 5. And if we do 4 times 9 times 5, you should get 180. So 180 is the least common multiple. So if we were to count up by 18, so like 18, 36, 54, and so on, you will eventually get to 180, as well as 20. If you count up by 20s, you'll get to 180 as well as 30. And that is going to be the lowest number, or the first number that matches when we're counting up by all three of those numbers. Our very last example here is just a little bit of a word problem, and yes, we have to get used to word problems in Precal, unfortunately, but it's okay, they're not that bad. So example 4, one neighbor cuts his lawn every 8 days, another neighbor cuts her lawn every 10 days. Suppose both neighbors cut their lawns today. How many days will pass before both neighbors cut their lawns on the same day again? So you need to recognize that this is a least common multiple question. So we're starting off on the first day, and we're going to count up by 8s, and we're going to count up by 10s until we get the least common multiple of the two. Now this question, you might be able to visualize or think about what the answer is because these numbers are so small, but we're going to use the math we just learned in the last example to figure this out. So we're going to need to find the least common multiple of 8 and 10. So let's do our factor trees for both of these numbers. So 8 goes into 2 and 4, and then we split up that 4 into 2 and 2. So the prime factorization is 2 to the power of 3, or 2 times 2 times 2. And 10 can go to 2 times 5, and then we're done. So the prime factorization of 10 is just 2 times 5. So if we're finding the least common multiple of those numbers, we're going to take the greatest power of each factor that appears. So we have 2's there, so we're going to take the greatest power of it. Well, we have 2 to the power of 3 and 2 to the power of 1. So 2 to the power of 3 is the bigger one. And then we have a 5 there, and 5 to the power of 1, or just 5, is the biggest one. So if we continued this, 2 to the power of 3, that's 2 times 2 times 2, which is 8. And 5 stays the same. So 8 times 5 is 40. So that is our least common multiple. And because this is a word problem, make sure you write a sentence or a final sentence to say your answer. So our final answer is 40 days will pass before both neighbors cut their lawns. So there's how you figure out prime factorization of a number, and then using the prime factorization we can get the greatest common factor and the least common multiple.